Hey, welcome. I'm Nathan, and I'm the head of developer relations here at Virtu. Virtu is the creator of the Anka Build virtualization software that allows you to create ephemeral or even persistent Macintosh VMs for your developers and their CI/CD. These VMs are isolated from the host, though you can mount a directory from the host into the VM. You can even attach multiple USB devices like iPhones for your iOS builds and tests. Your VMs can be suspended in a specific state, which you can then store in the Anka Build cloud registry. This enables you to pull the specific VM state and use it on any one of your Anka virtualization nodes. Usually those are Mac Minis or Mac Pros. We made it very similar to Docker and Docker Hub so that your developers will find it familiar and get up and running as fast as possible. So today I'd like to show you how to use the Android Simulator on host example repo. One of the problems at the time of recording this video and creating this repo is that the Anka VMs virtualization software does not support applications that need GPUs. So while you can run the Android simulator using CPU, it's going to be very, very slow and most of the time not even support processing. So you can see down here that we explain the problem, and then this repo has an example that you can run or you can just take from, which shows how to run the build and unit tests, which are just you just need Gradle command line for inside of the Anka VM, and then pass the UI test or the build to a host. It could be any host. It could be the host that your VM is running on, or another one that's specifically tasked for these types of things. And you pass that data, the build data, and then you can execute and run the Android simulator on that host, then passing back the status to the Anka VM, which will then complete either successfully or fail, and then complete your CI/CD job. So inside of this repo, the most important, this is just kind of a sample. Android provides a sample UI test project, which we've taken. And then what you really want to do is you want to go into this .github workflows directory, and then in the main.yaml. This is the GitHub Action YAML. Now we use our Anka VM GitHub Action. So you can see that we're on the marketplace right now, and it's got Anka VM, GitHub Action. It's currently in beta, but it is good enough for this example. And so you can follow the instructions here to get started using the GitHub Action. Otherwise, just come here and kind of see the flow and the pattern that we use to achieve what we need, which is sort of host level execution of the Android simulator through an Anka VM. So you can see there's a very typical format and structure. We then have the GitHub Action right here, and then we load our Anka template right here. I called mine Android Demo. The Anka run options, I'm passing in the environment variables. Make sure to pass in environment variables. It's very important because the GitHub Action runner will actually have environment variables that we'll use throughout. For example, GitHub Action right here, and then the GitHub Workspace environment variables. Those need to be available inside of the Anka VM, so we actually pass them in using the run option. This is wait for networking, and then wait for the Apple time to sync. And then commands. So I'm setting some stuff here so that we fail properly. First, let me explain that by default, you're mounting in the current working directory on the host into the Anka VM. So that will be available for us, though we don't want to run the build or tests from that mounted directory inside of the Anka VM because it'll take a performance hit. You'll see probably like it be somewhere up to 20% slower running it from the mounted directory. So what I do instead is I then cd into the user's home directory, don't even do anything from the mounted directory, and then I clone the repo. You can maybe avoid this clone and just copy the files from the current working or from the mount point inside of the VM, which is private var temp, and copy them into a folder inside of users Anka or wherever on the Anka VM. I actually just want to clone it to show you that that's possible. And then we do an export of some environment variables, which will set things up. I have Android Studio installed inside of the Anka VM. That's a very important requirement. I then check to make sure that it's there and exit otherwise. And then I set the Android home. And you can see there's some escaping going on here. If you read the documentation for the GitHub Action, you'll note that we do mention that you have to escape certain types of characters that are under commands, just because they'll interpolate either on the host level and not inside of the Anka VM, and you don't want that to happen. You want home from the VM itself, not from the host. So you have to escape things like this. Then what we do is we do a quick Gradle clean, stop and clean, which likely isn't necessary because this Anka VM is in a specific clean state when I start it. So, but I just put these here to show you. Then we assemble the debug APK. Then we run a test, which is the unit tests. All of this is happening inside of the Anka VM. Then once I've got the test APK or the debug APK available and my test passed, then I copy all of the files from my current directory. And again, I'm in the Anka simulator directory. And I copy all those files in there back into the directory that was mounted from the host into the Anka VM. And so this will make files, my build data available and the APK available to the host. And so we do that copy, and then what I do is I grab the VM label, which is an environment variable that's made available. This will give me the name of the Anka VM, and I'll show you how that's used later. And then what I do is I then SSH into my host machine. So for me, I'm running an Anka VM on the same host machine that's going to run the Android simulator. So for me, I just want to go back out into the host, and inside of Anka VMs, you have the 192.168.64.1 available for that. And this will SSH back into my host with my user. And then I start executing commands. So I source in my ZSHRC, then I set the same set EXO so that it fails properly. And then I start setting environment variables. So the path needs to be loaded, Android home needs to be loaded, and you can see that I'm adding extra escapes here. This is because I don't want the path from the Anka VM to be passed in. I simply want to execute this. So remove these three backslashes and don't interpolate. The three backslashes basically mean don't interpolate this. Just execute this as if it was without the slashes and without interpolation on the host. So you'll need to keep that in mind. You have to escape things properly, and it can be tricky at times, but we kept it like that so that you have the flexibility to ensure that things aren't or are interpolated either on the host or the VM level. And so then we do the Android home. So again, we're using the home from the host itself. I have Android Studio installed on my local laptop here. And then the AVD name, this is the simulator that I want to use, and it's Nexus 4 API 30. I then set the port for it, and I use the AVD manager and SDK manager to set that up. So I create the AVD, and again, I specify AVD name, and I want this to be the environment variable on the host and not interpolated until I execute it, and that's going to use those three slashes, and it's going to interpolate this at the moment it executes, not before. Then device, and again the quotes I don't want to change at all. I want them to be exactly like this on the host when it executes. Same thing here, and then I'm going to force it because I just want it to run all the time. And even if it's already there. SDK manager, it's going to update. That's not necessary, but then what we do is we do something special here, and we execute with nohup. And some of this stuff is bashism. So you're going to need to look up what nohup does. I'll give you a brief summary though. So we're basically executing the emulator, and we're giving it the AVD name. We're giving it the port that it's going to run on. And then we're backgrounding the process. And that's what this and is. And we're throwing it into the background and sort of detaching it from the current terminal, which was opened here. So we're backgrounding it here, and then we're making sure that it stays running with nohup regardless of if this closes. And I'll show you why that's important in a second here. So if this session closes, I still want the emulator to stay alive. And so the nohup and then the backgrounding, I do both of those things, and nohup requires these right here to work properly. Then I sleep for 5 seconds so the emulator can start on the host machine. And then I just export this process ID to make sure that I can look it up later in case it fails. Then I CD into the GitHub workspace. So this is going to be the directory, the GitHub Action runner, which is running on the host, is going to that's the location where it clones and it keeps all of the data. So this GitHub workspace actually has all of the contents from the Anka VM that we CP'd. We did a CP from the Anka VM into the host through that mounted volume, and then we CD into that volume where that data is. And so then what I do is I run this VMWatcher script. And I'll show you the script in a moment here. And I run it as a daemon, and I pass in the VM label and then the emulator process ID. Now, let's go back to the repo root directory, and let's look at VMWatcher here. This is sort of a requirement in my mind. You can try a different approach. I decided to just create a bash script for this. What it's going to do is it's going to take that VM label right here, VM label, which is the VM name that's running, and then take the emulator process ID. And what this script is going to do is it's going to watch. It's going to keep watching using Anka show and then the VM label. VM labels is $1 here. And it's going to watch the status. As soon as the status no longer exists, so as soon as this show status returns exit 1, I believe, which is basically the VM doesn't exist anymore, I want to kill that emulator process ID, which is $2. Now, this is, again, necessary because the emulator was backgrounded, detached, and that means it's going to run indefinitely. It's going to run as long, even if this entire GitHub Action job finishes or fails or is canceled, it's always going to continue to run, and you don't want those piling up on the host. So I run this VMWatcher process detached as well, and you can see I do the detaching here. There's this trick of disowning. You can look all this up online, or you can use the example here and just kind of make certain tweaks if necessary. And so I not only have the emulator backgrounded and detached, but I also have the VMWatcher. And so both of these things are running independent from whatever is going on here in GitHub Actions and the GitHub Action runner. So what I do then is I then sleep for 60 seconds to make sure the emulator fully boots. This likely is going to improve. You could probably run some sort of command to watch to see if the emulator is ready, and then continue on. I just did a sleep because it always starts within a minute. And then the emulator name, and then I run the Gradle wrapper connected Android test, which will execute on this emulator. So, and then the UI tests run. So that kind of gives you an idea of how to accomplish UI testing and make sure you clean up properly. Let's see it actually in action here. So I'm going to go under Actions. And I'm going to see that one of these has finished. Let's see it running live though. So what I'm going to do is I'm going to edit this file, main YAML, and I notice there's a space here at the bottom. Let's just remove the space. All right, pushed, and we should see the action kick off. And I've got a GitHub Action runner already running. All right, there we go. It starts the, you can see it's doing the CD, users Anka, it's doing the clone, it CDs into it, it sets all the environment variables, then it runs the first command, which actually needs to download and install Gradle. So you can actually install all of these things and make sure the Anka VM itself has all of these dependencies before, and then it won't have to download it. So that's something that's available. You simply start your Anka VM, you run this once manually, it does all this installation, and then you suspend it and you push it up to the registry, the build cloud registry. And so that'll speed up your builds and tests. It's doing the unit tests on the Anka VM. All of this is happening inside of the Anka VM. Let's download a few more things. Now, again, all of this can be canceled at any time and the Anka VM will go away and you'll see a failure. But once we start the emulator, if somebody was to click this cancel, the emulator would stay running if I didn't have that other script, which is this VMWatcher script. So that's why we do that. And the emulator is now running. You see it starts preparing everything. It ran the VMWatcher, and you can see it passed in as the two arguments, the emulator PID, and then also the VM name, which is right here. So that's running. The emulator started right here. We're waiting 60 seconds for it to boot. And there we go. Now, the script is going to run that last Gradle wrapper binary on the host, not inside of the Anka VM, because we want it to then notice the emulator that's running on the host. There we go. It just executed. And we want it to notice it and then install the APK and do everything that it needs to. So here we go. Looks like it's installed now. And you can see this is you can see it's already doing this. I'm not doing anything right now. It's running these UI tests on its own on my host machine, and it's giving me the output within the GitHub Action. And so if this was to fail for some reason, you would get a failure back in the GitHub Action that's running, which is good. So you're able to remotely execute commands and get back the status from the host and whatever was happening on the host. And so we're going to actually see this complete, and the emulator's going to stay running for a little bit. There we go, build successful right here in the log. And then the post GitHub Action right here does a cleanup and it disappeared. So the emulator disappeared. So on deletion or stop of the, rather deletion, which is a stop and then delete of the Anka VM that we used, the VMWatcher right here will watch and then kill the emulator when it's ready. That's you can see all the log output here of the entire build and test. And we saw the build successful here. This was from the host itself, and then it did the delete of that VM. So hopefully that makes sense and shows you a pattern that you can use to test things out on the host and then get the information or response for whatever those actions are back into the Anka VM and continue on with whatever else you were doing if you need to, allowing you to then use application or run tests using the GPU of the host itself, since it's not available within the Anka VM. So great. If you have any questions, please contact support@veer2.com. We also have a Slack channel. You're more than welcome to come in there. Otherwise, thanks for watching.